Hello and welcome to Badger Talks Live Quick Picks, which brings exciting happenings, resources, and talent from your UW flagship campus to the people of Wisconsin and beyond. My name is Jake Cruz, and I'm from Madison, Wisconsin, and I'm currently pursuing a PhD in geography. I know a little bit about our speaker today since he's been my research advisor for the last 4 years. So, it's with great pleasure that I introduce Song Gao, Associate Professor and Director of the Geospatial Data Science Lab. Today, Song will discuss how the increasing use of location-based services has generated large-scale location data through mobile phone tracking, wearable sensors, GPS devices, and social media. These location big data provide new opportunities to study multi-scale human mobility patterns and human-place interactions, which are important in transportation management, public health, business intelligence, and many other domain applications. It also introduces grand challenges regarding broader ethical and policy implications. In this talk, the latest research efforts on human mobility analytics and protecting user privacy using various geospatial data science approaches will be presented. Dr. Song Gao is an associate professor in Geographic Information Science at the University of Wisconsin-Madison, where he leads the Geospatial Data Science Lab. His main research interests include human mobility and social sensing. He is the author of over 100 peer-reviewed research articles and one edited book. He was the recipient of the 2022 UCGIS Early Mid-Career Research Award and among the Web of Science Top 1% Global Highly Cited Researchers list of 2022. I'd also add that he's an incredibly caring mentor and research advisor who gives his full attention and help to everyone who walks through his door. So with that, please welcome Dr. Song Gao.
Thank you, Jake. Yeah, thank you so much for introducing me. And hello, everyone. My name is Song Gao. It's my great pleasure to join the Badger Live Talk today. I'm going to present to you the human mobility analytics using location big data. And please feel free to share your questions in the chat. We'll answer them after the live stream. So to get started, I'd like to introduce our research and then what are the data sources. So to conduct those data-driven human mobility research, and traditionally we'll hand out trip surveys and to ask participants about their daily itinerary and then where they go and what places they interact for their daily life and sharing individual experiences. And with the increasing availability of mobile phones, we start collecting like GPS trajectories and from the cell phone call detail records, as well as the georeference social media data such as Twitter, Instagram, etc. And during the pandemic, we also experienced a lot of increasing use of location-based apps to a lot of services such as healthcare and others. And lastly, and for a lot of autonomous vehicles and also those from the insurance industry, we also utilize a lot of so-called telematics data that is coming from those onboard devices in your car. So with utilizing those various kind of data sources, we can understand, human movement across different places and over time. And for other geography, then we can understand what are the underlying, land uses in different cities, what are the spatial and social interaction happening, and then how, human understand different place semantics. So during the pandemic, our group, study a lot of human mobility changes in response to the, pandemic. So at that time, we aggregate, over 45 millions of mobile phone devices over the whole United States, and then keep tracking their daily movements and to understand the disruptive changes to the daily lives for the whole US. So this is a dashboard, as you can see in the screen, that we created to have a daily checking about what are their movements, either increased movements showing in blue, or it is reduced movements. So we're showing in the increased movement showing in red, and then the reduced movement showing in blue. So this is we can keep tracking these changes and understand also how those mobility behaviors and associated with the various spatial temporal spreads. So our work was also reported by multiple media outlets. So in addition to the movements, we also interesting to understand what are the driving forces, what are the underlying social economic phenomena, what we can find from those movement patterns. For example, this is a study we conducted in Milwaukee, Wisconsin, and utilizing over 500,000 mobile phone device data, we can understand the mobility patterns of different socioeconomic groups, and we utilize the so-called community detection algorithm and apply in those spatial networks. We can identify those isolated community that have less frequent interactions outside their residence boundaries. So this is definitely a very interesting study, but also as we know that Milwaukee was among one of the most segregated metropolitan area in the United States. So as you can see from this figure, so those different color means those different neighborhoods identified by their movements, and the right cycle actually the pie chart showing you the race and ethnicity composition of this particular group. So if you look at those very limited activity space of their yellow community, you actually find a large green, which actually refer to a large population of their African American community. So versus the orange one, actually showing you a large race ethnicity is a large Hispanic community. So which is different from those Western suburb communities, and which are white dominant regarding their activity space. So in other words, we actually can track and understand different spatial patterns about human movement through those large scale mobile phone location tracking, and to understand not only the residential segregation but also their movement or activity segregation. And then, in addition to those social problems, so we also interested in their regularity. So we need to understand what are the underlying mechanism, and for example, their daily needs and constraints such as work, social life, as well as family constraints, and which drive when do they move and how they move, and then in what way, and also their occupation flexibility or their individual preferences, and whether they explore or whether they are just used to their daily routes. So in other words, we actually can have a different level of regularity regarding the location, regarding their activity type, also regarding the driving routes. So in one particular study, we model this different kinds of movements into a mathematical model in networks, and we choose like their visited location places as nodes and their trips between location as edges, and then we extract those different node attributes and edge attributes as well as the network structure. So we call the motif, which is showing the pattern of the movements among different locations, and also they're connected by the different trips. So you can see that one individual may have a commuting, but they also maybe go out for lunch or go to the school for picking up the kids and coming back, etc. So those are different activity chains. So if we keep tracking one individual, such as one personal driver, and over, like say, certain days, and then we can start extract those so-called patterns. So for example, if we look at location-based motifs, which mean that you look at those location clusters, extract from those GPS trajectories, and then you can look at what are their, location chain patterns. For example, whether it is more commuting like, patterns, or it's more explorer pattern, which means that this individual driver explore different kinds of location over, different days. And if you add in those place semantics, such as, whether it is a home, or it is an office, or it is, maybe other social life location, and then you can start building those activity-based motif, or so-called those, activity chains. So then we can start looking at, okay, whether one individual user is different from another, or they are similar, and how other patterns, keeping the same, or they are different across different regions and in different cities. So this is, how we look at so-called multi-level regularity. And this is, for example, look at the regularity in your location and as well as the in-activity motive, as well as the routing. So we came up actually over 20 different kinds of features to quantify the multi-level regularity about daily human mobility, patterns. So based on that, we can start looking at, okay, different types of users. We grew them into different clusters. For example, in this figure, you can see 5 clusters. We named them based on the different level of regularity. For example, the first 2 clusters, they are non-commuters based on their, location motive, but the other remaining 3 clusters, they are commuters because we always find those recurring commuting trips. However, if we look at whether they are home-based, we can further classify, for example, cluster 1 and 2. The cluster 2 have more stay-at-home trips versus the cluster 1, which is most likely that such as those ride-share drivers. We call it gig drivers because they are always driving around, and they do not have regularity in both commuting trips nor in their actual other type of places exploration. And versus if it is more like class 5, which is more work focused on commuters, they'll actually stick to their daily commuting trips. And so you probably were wondering which user you might be falling to. So that is really depending on your regularity about movements, among different locations, different places, as well as what kind of activity you are doing. So we came out with this framework, and we found a universal pattern actually across the major US metropolitan areas. So here on the map, they actually show those individual trajectory of those different users in one cluster. Okay, lastly, I would like to quickly share with you, in addition to the many interesting work about utilizing those location data to, do the mining of the patterns, explore what kind of users, as well as their, daily constraints. The increasing use of location data also pose important and critical privacy concerns. So this is why we came into our one funded research is about how to protect the location privacy. So first of all, location privacy, or we name it as geoprivacy, refer to individual rights to prevent their disclosure of their personal sensitive locations, including but not limited to the home, workplace, the daily activities, as what I shared earlier, as well as their travel trips. Because as you know that if you have the regular commuting train between one location versus another, such as your home to work, or even between home and then the other third place, such as the school, you actually, based on their patterns, we actually might be able to review who you are. So that's, which sounds scary. So this is why we need to, as a researcher, we need to put the one more care about, whether there is potential risk about the location privacy. So this is why, as a research, we want to have both sides of methods. On one hand, we want to do the data mining. On the other hand, we do want to protect the individual's geoprivacy. So this is this part of research, and there have been many methods about how to protect the user's GPS trajectory privacy. For example, you can aggregate the raw GPS location to like your neighborhood. Then your location might not be reviewed, to your individual, house or apartment. Second, we can also add a so-called some noise into the original raw data, and we call geomasking. So adding those different noise, and we can actually mask your raw data. The third method is called grouping, which means that you might group your individual trajectory with another one, and such that we cannot identify you. Last but not least, we also have the differential privacy. You can add those system level, noise into the database, such that individual cannot be reviewed. However, there is still challenge about the trade-off between the privacy protection effectiveness as well as the data utility. Because if we add too much noise to the raw data, then we will lose the actually data utility in downstream tasks. So for example, in a US sensor population data, they actually apply the differential privacy, so, which means that there is some uncertainty or noise in their sensor data. However, they want to guarantee that the downstream utility of such data will not pose any bias or any data quality issue. So similarly here, we want to evaluate whether increasingly popular like generative AI approach can generate synthetic trajectory data to individual users, and on one hand protect their user privacy, on the other hand has a good data utility. So this is one example. So on the left is a real trajectory, on the right hand is a synthetic trajectory that we generated from our generative AI model. You can see they are very similar. However, in the downstream task, when we threw the synthetic trajectory back into the original raw database, we found that our proposed approach that one highlighted, the ARSTM trajectory again, this generative AI approach actually has a lower performance about their accuracy about trajectory user linking, which means that actually have a very good privacy protection, because giving any trajectory, we only have a less than 50% of accuracy to identify who you are. So which is much lower compared with the raw data, which is over 93%, which means that you give me your individual trajectory, I have over 93% of accuracy to know who you are. So in summary, so here in this short talk, I present you a set of data-driven mobility research from our lab. We also propose some model to understand the multi-level regularity in human movements, as well as sharing some thoughts, about protecting the location privacy with their GeoAI approaches. I do want to acknowledge the great students I have in the lab. They do their great works, as well as their funding agencies for their support, as well as the data providers. So without them, we cannot achieve this. So with that, I will conclude my presentation today, and please feel free to type your question in the chat. Thank you.
Thank you for watching this Badger Talks live event produced by the University of Wisconsin-Madison through UW Connect's outreach and the Office of State Relations. Follow us on Facebook and YouTube to see the library of past recorded talks. Please visit badgertalks.wisc.edu to see the schedule of upcoming talks, sign up for the Badger Talks email list, and search the roster of over 400 UW experts who are available to give talks on important issues in your